was to talk about the Nexsan unified storage platform, and we'll talk a little about performance and how it works. But the idea is, what is unified? If you're not familiar with it, unified is the combination of file and block storage within the same platform. Prior to the, in years past, in my career, we had a SAN and we had a NAS, and they lived apart. And then along came there are other vendors. There is one other vendor, actually two now, that actually provides a true unified storage platform, and everybody's heard of one. And I'll mention their name is NetApp. I mean, they certainly can provide a unified storage. But unified simply means the ability to provide out multiple protocols, both block and file, in the same system. The hybrid portion is where we take in, and this is our fast tier, it's our caching technology. We utilize a combination of DRAM and NVRAM, or non-volatile RAM, and then either SLC or eMLC SSDs to provide the caching level, the read caching level. So the DRAM is for the writes, the SLC or eMLC is for the reads. I will mention that SLC is probably going to go away. The technology is close to reaching its end of life, and it's being replaced by the eMLC because it provides better capacity, much higher capacity at a relatively close performance for a much lower price. So you'll see SLC kind of disappear from the market shortly. And then the storage on the back end, what ties it all together, is a combination of devices that we provide. And in our case, it'll be either 7200, SATA drives or nearline SAS. SAS drives, either 10K or 15K RPM. And of course, we can also do a storage tier of strictly SSD, in which case we will be utilizing the higher capacity eMLC drives now. We've stopped using the SLC drives for a storage tier, but we can still use it for a caching tier. And if anybody ever wants to get more detail on that, we can provide them information about the differences of the SSD drives. Again, why would I do this? It's really the ability to consolidate your storage, provide a platform that's going to serve out all of your information, allow you to shift your work and your storage between platforms as needed, the ability to grow each platform, whether it be a SAN or a NAS. I create a storage pool, and from that storage pool, I then serve out the LUNs or the shares. So it gives me a centralized location from which I can serve out all my different I/O and provide all my different needs from a storage standpoint. Again, another reason why, especially where you want a unified or a hybrid platform, would be the fact that I've got different types of applications coming on. VMware has effectively created a random environment regardless of whether you're doing random workloads. And that's where fast tier comes in. The idea behind the ability to serve out all this information, to serve out shares and LUNs with utilizing different underlying storage in the back end, just gives you that ability, as I mentioned, to grow it fast, to grow it easily, and make it much, much easier to manage. And that's what our Nest OS does. The underlying piece of this is our UI, the eCenter UI, as well as the Nest OS. I mentioned before, but repeating, the hybrid part, this is because everything has become random. When I take all these different workloads and I create all these VMs, I create a random environment. And random is the one thing that disk storage doesn't like to do. And that's where the fast tier comes in. The fast tier is that layer, that caching layer, the combination of the DRAM for the writes, the random writes coming in, and the random reads is the SSD-based flash drives. And the use of the two of them together mitigate the issues that you run into with the hard drive. So if you're familiar with hard drive technology, they do have limitations. The nearline SAS, limitation of under 100 odd random IOPS. The SAS drives, a limitation of about 175 random IOPS. And then you get into SSD, and SSD becomes really fast for random IOPS, not much better for sequential, but better. But it can handle the read and write random IOPS very, very well, but it's a very expensive technology. So by layering it in there with that hybrid piece of the DRAM for the writes and the flash for the reads, I can keep the cost down while providing you the really high IOPS that are all SSD or all flash system. It just does not have the ability, or the cost becomes prohibitive. And having said that, I don't want to present the thought that an all flash tier does not work. We actually sell systems that are all flash based, but they are really designed around a very, very specific workload, not a general VMware workload. So moving up the different platforms or the different models. We have 5 models from the 5130, and the 5000 series, as I mentioned, has been around since 2010, late 2010, early 2011. The 6000 series, about a little over a year ago, the Metro Cluster version came out, and about 6 months ago, we came out with the 6530, which is the data center version. The Metro Cluster is the HA version, where I have controllers in separate locations, storage in separate locations. It is a true HA environment where no single point of failure can lose access to data. It's designed to cross cable between multiple sites or just have 2 systems as a never-ending running system within your own data center. And then the 6530 came in second. As I mentioned, we went for the hardest thing first. And then we brought the data center version in because we were handling most of the data center requirements with the 5530, but then the fiber channel connectivity is what I have different in the 6530. So the difference between the platforms, since they run the same software, the real difference is the controllers of the 6500 will support fiber channel as well as 10 gig iSCSI and 1 gig iSCSI, of course. So looking again at the platforms, the 5100 is our true entry level. It basically can get me, it can get me up to 128 terabytes. I'm sorry, I just saw a note come in on the sound. Hopefully everybody is hearing the sound okay at this point. In the 5100, it can grow up to 128 terabytes. It just depends on whether or not you're using 4 terabyte SATA, and it can have up to a total of 32 drives, or I can have a mix of drives and then put up the 4 fast tiers. So I have a total of 32 slots. So it is a true entry-level device. It's not going to grow into the petabyte range. The 53 and the 5500, which came out at the same time as the 5100, as you can see, the top unit, or the actual appliance itself, has no spinning drives in it. It is only used for caching technology, up to 16 SSD drives for the caching tier. And then the storage on the back end, depending on what we're looking to do within the system or what you're looking to do, is either going to be our 224X, which is a SAS or SSD-based system only, or our E-Series storage, which, by the way, has been around. The E-Series has been out for approximately since 2010, is when we introduced that, when we changed our series over to the E-Series. It will provide either SAS drives, nearline SAS drives, SATA drives, or we can even do an SSD tier within that. The interesting thing that may not be known by everybody is our E-Series storage does support a mix of any type of drive. So I can put multiple tiers of storage within a single Nexsan E-Series storage. Okay, I think I'm back to where I was. The 6530, the real difference, as I mentioned, in the 6530 is because it was designed around metro clustering and designed for HA environment, instead of having dual controllers, which the 5000 series has dual controllers in a single appliance, the 6000 series, whether it be the metro cluster or the DC, as you see here, is going to have 2 separate appliance heads. So we'll utilize 2 heads along with additional battery backup to provide, because and you'll see why, we increased the amount of fast tier and caching as well as the amount of memory in here, so we needed additional battery backup. So the 6000 is 2 separate units, but it does support the same storage on the back end, the 224X, whether it be SSD or SAS, or the E series with its mix of drive types. And to the side, you can just see some pictures of a blown out system where you see, at the top of the system, we've got the 6000 series, and in this case, I've got a grouping of our E series storage. And again, on this side, I've got the same system with a grouping of the 224X, and I can support both platforms within behind the same storage units, behind the same appliance. One last thing, I'll tell you about the Metro cluster. As I mentioned, Metro clustering, if you're not familiar with it, this is truly your high availability disaster recovery. Picture does not do it justice, but effectively in this system, there are no single points of failure. I can lose anything within this system, any one of the components, and the other one will automatically take up for it. So everything is cross-cabled, from the switches to the storage to the head units themselves, to be used in separate locations, even to bypass a power failure. If I had a power failure at one location, the other system is always up to date. It's run in what's known as a synchronous environment, so that no I/O is not complete to any location, and it's just on the fly, just picks up and takes over. And it's known as, we call it Metro clustering. I believe a few other vendors call it that. There may be other names, but the idea behind it is you've clustered your storage, and it's safe, it's secure, and it's nonstop. The standard operations that you get with either the 5000 or the 6000 will provide you with asynchronous replication. And that is, if I want to do a long distance replication between two cities, New York City and Los Angeles, that is what you get automatically. The system will automatically ship with the ability to do asynchronous replication. So as long as I have two sites, I can do that. And it can be a many to one. Or even one to multiple sites if you choose to do that. So how you set up the replication is up to you. It is a point-in-time replication, so that it's a snapshot base, so that you always have a fallback point, and you know exactly where that point is. Very granular in terms of how it can be done. It can be done at a share level or a pool level, or for that matter, a LUN level, if you're doing block storage. It does utilize deduplication and checkpoint restarting for anything that's going on. And just to mention that deduplication, that's a WAN efficient deduplication, not to be confused with actual storage deduplication. Now I'll back up and start at the top. One of the things I mentioned was the ability to add storage on the fly. That's the one thing that a common unit will give you. I can create a storage pool, and then as I add capacity, I just add it to that pool or create a new pool. Very simply done through the web UI. You just add storage or create new pools. And this is basically available because of the underlying technology that uses oversubscription or thin provisioning, depending on whether you're in a block or a NAS environment. Data compression is available on both the 5000 series as well as the 6000 series. It's customer choose, you get to choose what pools you want to apply it to or not apply it to. And in the case of the 6000 series, in the very near future, you'll be able to do deduplication. And this is actual data deduplication at the appliance level versus the WAN efficient deduplication. Also, what comes with the system is snapshots. They are a capacity-less snapshot or a redirect on write technology, and that means simply that I do not have to set aside storage in advance if I choose to use snapshots. Many of the technologies today that are out there will see, a copy on write. They'll use a copy on write technology, which requires that you set aside storage and has to be planned for in advance. This technology does not. The only other thing I'll mention here on the snapshots is it says up to 2,048 snapshots per share or LUN. You can actually do more than that, but we needed to put a number on the slide. We have tested it beyond 2048. I don't have any customers yet that need 2,048 snaps of a single share or LUN, but again, it's a number that I had to have something, but it can go beyond that if needed. One other thing you get, depending on whether you're choosing NAS, now the 6530 does come as both a block as well as a file system. The 5000 series, I can get it in either or both. So by the feature set in a NAS, it's a simultaneous CIFS and NFS, and that's serving out an individual share as both CIFS and NFS. And the key there, if you're familiar with the two technologies, you have to follow all the rules that are set forth for permissions, and we'll do that. We will support both types of permissions. There are some caveats. If anybody's done that you need to be aware of. There are some simple rules that need to be followed, and we follow those rules, and as long as you do, there will be no issue with serving them out as both. We support Active Directory and LDAP, as well as we have an internal security system if you don't use them. I mentioned oversubscription. So in a NAS world, we use quota management and oversubscription. Background data scrubbing goes on in both systems. I'm not quite sure why it's only in my one NAS feature set, but both the E-Series as well as the NSD 5000 and 6000 will provide for data scrubbing throughout the system, throughout the life of the system. It's built into the system. iSCSI, we support up to 64 terabyte LUNs today. Thin provisioning is built into the system. So thin provisioning, for those that aren't aware of it, that's the block version of oversubscription. It allows me the ability to say that I've got a lot more storage that's there, and that's very useful in a system where I can add capacity on the fly. I buy what I need today and grow into it, and as I physically use that, I can add more physical storage to that pool. In terms of what we can support, in an iSCSI set, right now we have both VSS hardware support for Windows, VMware VAAI support for the iSCSI set. We are fully VMware compliant. We are adding the VAAI feature set. That should come probably in the next month or so in the NAS environment. If you're familiar with VMware, you have to go through each of their phases for every protocol, for every feature within there. So we have to go through a series of test all the NAS with the 10 gig iSCSI, 1 gig iSCSI. I have to do all of the block storage at both fiber channel, iSCSI, all of that. So I have to go through all these certifications, and that's what's underway now with the addition of the fiber channel. And then we're adding in the 10 gig. That's being done in the NAS now. I'm going to take a quick breath and throw up a new technology here. From a back-end storage, I just wanted to mention the E-Series because it is what we've been doing for a long time. Very unique storage architecture. It is the storage that we use for the capacity-based systems. You can see there's 3 units here. It's an E18, which is an 18-drive unit, E48, and an E60. There are 48 drive unit and 60 drive units, respectively. They use what we call an active drawer technology, and that is once the unit's in the rack, there's no cable management required, no reason to go behind it unless I'm adding more connectivity to it. When I open a drawer to add capacity, the drives stay active. So you do not have to stop the system or quiesce the system. You just simply open the drawer, add new drives in, present it out to the NST 6000, and then we'll then form the RAID sets and then put it into the storage pools that you choose to do so. And the reason I mention this is it's a very unique architecture. I don't know of anyone else that's using an architecture like this. For those of you that can really see this well, you'll see that we use counter-rotating drives. The drives in the 48 and the 60 are mounted vertically and in 4 rows, and 2 rows are spinning in one direction, 2 are spinning in another. What we're trying to do within this system is eliminate vibration, which causes drives to wear out and causes drives to fail. Drives do not like heat. They do not like vibration, and surprisingly, I'm sure everybody knows, they do not like to be powered on. We can't control really the powered on part, although we have technology built into our E-Series to make it a very clean power on so that we don't get a power surge, which can take out the electronics. But as far as the heat, we have a cool drive technology, which is simply fans in the front and rear of every one of the drawers, and we channel that heat away from the controllers and the electronics in the back where your controllers. Again, a dual redundant system throughout. So even the E-Series storage, not only we have 2 controllers in the NST, we have two controllers in the E-Series. Additionally, when we use the E-Series, we offload all of the work that's provided for RAID calculations, whether it be RAID 10, which of course really has no calculations, it's mirroring, RAID 5 or RAID 6, that work is handed off to the controllers on the E-Series. They're intelligent controllers and have their own caching to do that kind of workload. And one last thing on the E-Series I will mention is the fact that we have built into these what we call an automate technology. So if you're building a very large infrastructure, we can actually spin the drives down and put them to sleep when they're not in use. That does not hurt the drives at all. As a matter of fact, depending on who you listen to, it can actually extend the life of the drives. I don't know that to be a fact because I've never measured it, but there are articles been written by third parties that say putting them to sleep is a good thing. We have never noticed any difference in terms of a fully active all the time versus a system that's using automate, but it's a very useful feature if you're looking to save some power and cooling money and you're building a large deep archive or something along those lines, or even for disk-to-disk backup. I won't spend a lot of time on this chart as it's probably hard to read. It's just showing you that, again, the E-Series and the capabilities. Each E-Series unit can expand 2 additional expansion chassis. So at the high end, and what I like to refer to as the golly gee number, when I take an E60 series, I can expand it out to 720 terabytes behind the controller. And this is very, very useful if you're building deep archives. And some of the customers that were on that customer list in the beginning, that's exactly what they're doing. Huge deep archive, multiple petabytes of storage behind the E-Series controllers, and they're saving money using that same technology for the automate. Okay. Fast Pure. This is the performance part here. This is where you get the ability to really bump up the performance capabilities of a storage system. And what it's really doing, if you think about controllers and I/O, as I mentioned, spinning drives cannot do a lot of I/Os. So in order to get a lot of IOPS, which is what the new world depends on now, because I've got all these VMs and they're all creating what used to be sequential workloads into random workloads. I need a way to take a drive that is not capable of doing that and giving it that high I/O capability. That's what fast curing does. So when I/O comes in, every write comes in, it's going to go in the main memory, and then it's going to be written to a DRAM write cache. So I've effectively done what we call a fast write. So immediately I can reply back to the OS, okay, I've got that data in 2 locations, it is now secure, it's done. And now I can go and take that next write. When I'm drive dependent, I have to wait for the acknowledgement back from the hard drive. So we eliminate the write penalty associated, and by the way, drives do writes worse than reads. So that's taken care of. So I have up to 64 gigs of fault-tolerant write cache in the 6530. In the 5000 series, it's done a slightly different way, and I can actually have just as much. It's just not necessarily going to be DRAM based. It'll probably be NVRAM based. The read cache is just a set of SSDs. All right, I can have up to 48 read caches assigned to a given underlying disk storage. There are 24 slots in each of the 6,000 heads for read cache only. So it's all sitting there waiting for me to designate how I want to divvy that up. So when a read occurs, or even a write, let's just say a write occurs, it's going to come in, it's going to go into DRAM, and then we're going to stage it into the read cache in case it's reread. So it's written, acknowledged, put in the read cache in case it gets read again, and then an algorithm will control whether it stays in there or not. And then for a normal read, reads are going to occur from the back end. The first time I read data that I haven't used before, it's going to be referred to as a read miss. Subsequent reads will be read hits. And I will keep that data in there as long as it's busy. And since I can divvy this up and serve this out to different pools of storage, I can control who gets what I/O and how it's, how the loved ones are going to perform. when I look at it, this is just showing me different levels of, what's going to do the right thing for the right price. Again, I don't do the pricing, but we all know that SSD-based systems are going to be the most expensive. If I use all nearline SAS or SATA drives, it's going to be the least expensive in terms of storage. So depending on what I'm going to do and how I divvy it out and how much cash I put in, it's going to control the amount of IOs I can get as well as the cost. I'll throw some numbers out here, and these are high-end numbers, and it's very clearly stated here, and I want to make sure everybody's well aware of that. These are read cache performance or read hit performance. This is not the norm, but everybody likes to publish their really high-end numbers and what can I do in a system. That's exactly what this is. So if I get my data and for example, I have a SQL database, and that SQL database is just being hit really, really hard, and it happens to fit inside my fast tier. So if I've got enough fast tier in any of these systems, these are the numbers I would get. That would be a cache hit. Every time I do a read on that SQL database, it's considered a cache hit, and I can get some incredibly high IOPS numbers. As everybody knows in performance, much like buying a car, your mileage will vary based on the read-hit ratio. So if you get a good read-hit ratio, or if you got a good what we call locality of reference, you're going to get incredible performance out of the fast tier. If you're in the middle of the road, then your performance numbers will be like that in the middle of the road. And then if you have a very poor, truly random and not enough cash to put it in there, you're going to be drive dependent. So your mileage may vary, but we try to tune the system to meet what you're going to need and try and match the right cache to where it's going to be the best utilized, so that we don't put a bunch of right cache into a pool of storage that will not get any benefit. We'll put it over on that pool that will get that benefit. Just a few more slides. I wanted to talk a little bit about the UI. This slide here does not really do it justice. It is an incredibly unique UI. It's a single pane of glass. Everybody talks about that single pane of glass. It's a true single pane of glass, regardless of how many NST systems I have in here. It's a drop-down hierarchical menu. So as I click on an icon within the system, for example, if I clicked on this, and you can see in this case they clicked on a storage pool, and this is one storage pool. As I click on each of the icons, it drills further and further down. And it's probably a little hard to read this slide, but what they're doing is they're drilling down here. They're looking at the permissions. The last icon is that they're looking to get information about the permissions for that specific pool of storage or share. And anywhere you click within the system, that's exactly what it's going to do. It's going to line it up under there. And if I have multiple NST systems, they'll all appear on the top line. So up in the top bar, you'll see all of these systems that are installed, or all of the systems that you've decided you want to can manage from this one UI. So you don't have to. And they'll appear up there, and as you click on it, all of the information about that will come down underneath. It's very wizard-based for those that like to use wizards. It also has a very robust CLI for repetitive tasks if you want to use the CLI to do a lot of the features. I have lots of customers using both. So it really depends on what you're looking to do in terms of ease of use. Also built into the system are a set of performance and reporting systems in there, as well as notifications for email alerts. In terms of if you're looking, you want to manage the system or monitor the system, its ability to do that. You can have emails sent to not only yourself, but sent to Nexsan for proactive management. There's also what's not listed on here. We also have a built-in call home feature where we will automatically, if you choose to do so, we'll weekly send a log to our support center. It will be reviewed, it's basically automatically be reviewed once it's received, and anything that's going on within the system, we'll know about it and we'll contact you and let you know that you've got something in the system. And this coming from the log will be something you'll get probably prior to ever getting an email alert on that. We'll see that tolerance levels are reaching a point within the system that we probably want to take a proactive step rather than wait for a failure. So kind of conclude, I've got about 7 minutes left here. You know, the idea behind the storage appliance was to provide efficient, unified storage, give you that hybrid performance without building an all SSD tier, and the ability to take different types of storage on the back end, from our 18 drive unit to our 60 drive unit to an all SSD based 224X if that's what you're looking for. And I keep talking, you know, about SSD and building things out on SSD. In the case of an all SSD system, we actually do not turn on the fast tier because it would be kind of double-edged, doing the same thing twice. The write cache comes into play, but we don't utilize the read cache in an all SSD base. So although we could, it's just we're caching incredibly fast storage devices already. So it's not normally something you would turn on. And again, no sense buying something you do not need or will not use. And wrapped around the whole thing, as I mentioned, is our integrated UI along with the Nexsan Nest OS. Very highly tuned system. We're very careful on how we release systems. That's one of the things Nexsan is known for, is their high availability, for their high reliability. It's what we've always done. So while others will just jump out and throw a feature in there, we test that feature every way we can possibly think before we'll release that. It's just built into our DNA at Nexsan. And with that, I'm going to say thank you.